Alright, what's up guys? In this video we're going to pick up with some differential equations, and we're going to be talking about exact ordinary differential equation today. So we're asked to solve the exact ODE. We're given 5x to the fourth y cubed plus 6x squared y minus 14x dx plus 3x to the fifth y squared plus 2x cubed minus 6y squared dy is equal to 0. So solving an exact differential equation isn't difficult. It just takes a little practice. So let's just quickly talk about the form. And by the way, I have more than one video on how to solve these, so you don't have to just watch this one video. And obviously you can ask me questions at any time. So the form of an exact differential equation is going to be this here. M of x comma y dx plus n of x comma y dy is equal to 0. The first thing that you really want to do, I don't know if you have to do it every time, is you want to use the test for exactness to just verify that in fact the equation is exact. It's just a fail-safe method for me, just to make sure that the equation is exact before I try to solve it. And the test for exactness, for the most part, like I said, as long as you know how to take partial derivatives, the test for exactness that you want to try to run at the beginning won't be hard to do at all. Remember, for the test for exactness, the partial of m with respect to y needs to be equal to the partial of n with respect to x. And again, 9 times out of 10, if your professor gives you an exact equation on your quiz or test and says, okay, solve this exact equation, 9 times out of 10 is probably going to be exact. But it is not unheard of for professors to trick students. The equation is not exact at all. I've heard of it happening. So as a fail-safe, I highly encourage you to just quickly run through the test for exactness, verify that it's exact. It won't take you a long time at all unless you are struggling with partial derivatives. Just verify that it's exact. It won't take you long at all. And once you've done that, and it kind of clears your conscience a little, that in fact you're working with an exact equation, then you can go ahead and solve it. So I highly recommend doing that. I do that because it just makes me feel a lot more secure that it is in fact an exact equation before actually trying to deal with it. So all you have to do for this is just identify what the m of x comma y is, and then the n of x comma y is, and then you do it from there. So the m of x comma y in this case would just be 5x to the fourth y cubed plus 6x squared y minus 14x. That would be your m of x comma y, and your n of x comma y would be this over here, 3x to the fifth y squared plus 2x cubed minus 6x squared. Excuse me, 6y squared. Sorry about that. So that's what your n of x comma y is. That's what your m of x comma y is. Now we'll quickly just run through the test just to validate that it's exact. So we'll take the partial of m with respect to y. So we just go over here, take the partial of all this with respect to y. That means we're treating x as a constant. So if we do that, looks like we'll get 15x to the fourth y squared. Looks like we'll get plus 6x squared. That's what we'll get for that. Now let's do the partial of n with respect to x. So we'll go over here and we'll take the partial this time with respect to x. That means we're treating y as a constant. And so in order for this equation to be exact, these partial derivatives need to be equal to each other. And it looks like they are, because we're going to get 15x to the fourth y squared plus 6x squared. That's what we get when we take the partial derivative on that side as well. So clearly we can see that for the test for exactness, it clearly passes, and this is in fact an exact equation. So it just makes me feel a lot better to verify it. So you can say verified. It's exact. Okay, so now that you've taken care of that part, you can solve it. So remember the solution form for an exact differential equation. Let me write that for you. It's just going to be f of x comma y is equal to c. So what you need to do, you need to choose to integrate either m of x comma y with respect to x, or integrate n of x comma y with respect to y. Typically, it doesn't really matter which one you choose, although one may be easier to integrate than the other. but it doesn't matter which one you choose. And then once you do that, you'll take the partial derivative with respect to, let's say, for example, if I was integrating m of x comma y with respect to x. Well, then that means after I've done that, I would then take the partial derivative of that f of x comma y with respect to y. And so that's basically how you would do it. Again, it doesn't matter which one you choose. I'm just going to integrate n of x comma y with respect to y. Neither of these is harder to integrate than the other, so it's not a big deal. So what I'm going to be integrating is 3x to the 5th y squared plus 2x cubed minus 6y squared. I'm going to be integrating all of that with respect to y. So if I'm integrating all of that with respect to y, then it looks like we'll end up getting 2x cubed y minus, looks like we're going to get 2y cubed plus x to the 5th y cubed plus g of x. Okay, the next thing that we'll do is we'll take the partial derivative of all of that with respect to x this time. So we're taking the partial derivative with respect to x of 2x cubed y minus 2y cubed plus x to the 5th multiplied by y cubed plus g of x. Okay. So if we do that, it looks like what we're going to end up getting is 6x squared y plus 5x to the 4th y cubed, and when we take the partial respect to x for g of x, we get g prime of x, and then this will be plus g prime of x. So that's the partial derivative there with respect to x. The next thing that we need to do is we need to isolate the g prime of x, and so to do that, we're just going to take this and we're going to set it equal to our m of x comma y, where is it at, which is this here, and we'll try to isolate this g prime of x, at which time we can integrate both sides to solve for the g of x, and then we'll pretty much be done after that. So let me get another sheet to quickly do that. So again, it's not, when I first started learning these, it was a little difficult, but again, as with anything in math, it just takes a little bit of practice. So we're trying to isolate the g prime of x basically. So let's just go ahead and do that. So we'll set we'll have 5x to the 4th y cubed plus, and we're just going to set, everything equal to each other basically. That's what we're going to be doing. Plus 6x squared y, okay, minus 14x. And we're going to set that equal to, and since the 5x to the 4th y cubed was on the outside here, I'm just going to bring it on the outside on this side as well, which is perfectly fine to do because I'm not changing the value of anything. And then this would be plus 6x squared y plus g prime of x. So clearly all we really need to do here is subtract 5x to the 4th y cubed plus 6x squared y from both sides. And if I do that, that means that over here I'll end up with negative 14x is equal to g prime of x, which is approximately, which is the same thing as g prime of x is equal to negative 14x. It's the same thing, I just flipped it around. And the reason for that is because once I subtract all of this from that side, or this side here, well, obviously the only thing that's left over here is the minus 14x. And then when I subtract it over here, notice how this is the same thing as that. So that obviously is going to subtract away to 0, just leaving the g prime of x. So you would just end up with g prime of x is equal to, or negative 14x is equal to g prime of x. If you want to flip it around, which you perfectly can do, just write it as g prime of x equal to negative 14x. So that's what you get when you isolate the g prime of x. And now all we need to do is to solve for that solve for g of x. So all we have to do is integrate both sides of that. So we'll integrate the g prime of x, and then we'll also integrate the negative 14x with respect to x. So integrating g prime of x just gives us g of x. And then if we integrate negative 14x with respect to x, we'll get minus 7x squared plus c. Now we know that the solution form will just end up being f of x comma y is equal to c. So we can go ahead and write our final answer down here for the exact equation. So it looks like we'll get f of x comma y is going to be equal to, or f of x comma y is equal to c, and what we're going to end up getting is 2x cubed y minus 2y cubed plus x to the fifth. It's going to be y cubed, and then it's going to be minus 7x squared, and that's going to be equal to c. And that'll be the solution for that exact differential equation. And that's how you solve it. All right, so to really get good at these, like I said, you just got to do a couple of examples, but they're pretty fun to play around with. So give it a try and see how you do. So if you got any questions about how I arrived at my answer, feel free to ask. I have no problem answering questions. All right, guys, that's it. I'll see y'all next time.